Hello everyone, thank you for joining my session. My name is Michał Brygidyn. I'm AWS Ambassador and AWS Community Builder. I also work as a Cloud Solutions Architect at Zibia, but today I want to tell you more about what I do after hours, when I wear a white hat and I try to find leaking data in different companies and then report it responsibly. Last year, I showed you how I was getting admin access to your AWS accounts. If you missed that session, you can easily find it on YouTube, Cloud Hacking Scenarios. This year, I will show you what to do if you already have admin access to someone's account. I'm not sharing this to encourage you to hack into someone's accounts, but to let you know what attackers can do when they got into your account and how they will try to stay there forever. But let's start from a question. What's a backdoor? A backdoor, I'm pretty sure that at this conference you all know that it's a method of accessing your infrastructure, your applications and services that is bypassing all your security controls. So you are not, it was not supposed to be there, but for example, it was created for debug purpose. Developers left the debug toolbar, which was a backdoor for me. Or it was just a misconfiguration, leaving something in public subnet with public IP instead of private one. Sometimes backdoors are created by attackers, like me, for example. If there is a backdoor, you can be pretty sure that someone will try to get your data and to exfiltrate your data. And maybe they will even try to do some changes to your infrastructure, to your applications. If they have admin access to your application, they will try to list your users, invoices from your web stores, and maybe change prices just to mess with you. And if they can get into one of the devices in your network, they can probably access other network resources starting from that one. I will focus on AWS and I will show you how I create these backdoors, how you can identify that there is a backdoor, and how to prevent me from creating backdoors in your AWS accounts. And at the very end of this presentation, we'll play hide and seek, where I will show you how my backdoors can have self-healing and how they can hide from you. But first, entry points. If you want to interact with AWS, you can start with a root user. That's a user that you get for every single account. When you create the account, you get the root user. That's email and password. And that's a user that you should not use. Then we have IAM resources, like IAM users, roles, and other access methods like identity providers, SAML or OpenID identity providers configured with external identity stores. We have trust relations allowing external roles to access your roles on your accounts. Then we have servers with IAM roles that are running some tools, some apps, and these servers can be accessed via SSH, for example. But also, these servers, if you run it in the cloud, so this server has to start somehow, and you usually have init script. So if I am able to update your init script, I can implement my backdoor before the server even starts properly. Then we have network level, and here usually I don't get access to AWS API, but with access to network, I can talk to other network resources, and usually if these resources are in your private subnets, there is no security around them because, hey, only we have access to that. And at the very end of our interaction with AWS, we have services, AWS services, which take some input data and do something based on this data. So let's start with my entry point. I found a Kubernetes control plane publicly exposed, so anyone can just access it. And if you remember my presentation, it's like 200 new IPs with Kubernetes every week. On that Kubernetes cluster, there's Jenkins running, and Jenkins with a role that allows this machine, this pod, to interact with AWS as administrator. And this account was pretty big. Numbers are in US dollars. And we're in. Now we want to stay there for a bit longer. So let's start with the most common backdoors group, IAM. First backdoor, very simple. Just create a new IAM user. And it's simple because it gives you direct access to AWS. And you can create access key, so instead of username and password, you can just grab access key and use it in your script, automate everything. And if a company who runs that AWS account is using AWS SSO or other way in, they are not looking at IAM users, so it can stay there for some time. If they are using IAM users, you should first list all existing users and create your user looking similar to existing ones. And then either attach a policy to that user or add it to a group. And based on the policy, you can have your admin access. What's needed? First of all, IAM create user and create access key. These actions are useful to create that, are required. And that's all. So if you can modify existing users, you cannot create one. But if you have permissions to create a user, create access key, and assign a policy, attach policy, or put policy, then you have your first backdoor. Let's jump straight to second backdoor. We don't need to create a user if there are already users, IAM users, with interesting IAM policies attached. We can just find a user that has only one access key created, and there's limit of 2 per user. So if there is a user with access key, just create a second access key for that user. Nobody will notice that, because usually IAM users are not part of the infrastructure as code. And if you add that, you have the same access level as that user. And if you want to find if there is anyone trying to exploit your user, just check if any user has 2 access keys. And usually 99%, it means that the second access key does not belong to the person who created the user. So here, the only thing needed, IAM create access key. We are starting with admin access, but here I show that I only need this action to perform this and to get my second backdoor. How to prevent it? Let's say we have AWS organizations and we have service control policies. And by service control policies, we can protect our member accounts. Service control policies, which are used on the master payer account, protect our member accounts. They do not protect our master payer account. And one thing that I want you to remember from this presentation, principle of least privilege. If you don't give too much access to your resources and users, then I will need more time to get admin access on your infrastructure. But if you give admin and I access that, then I can do whatever I want. So you can use service control policy that protects these 2 actions, create user and create access key, and denies creation of this unless you are a privileged role. So let's say you have security account that runs user creation and key rotation, and only that privileged role is allowed to create new users. Then let's jump to another backdoor, and this one is interesting because it's hidden, and it's a trust relation between IAM roles. Let's say you have IAM role for your EC2 that gives you admin access. It's Jenkins and it's admin access. And I have access to your account, so I just need to modify the trust policy for that role, trusting my external account. It can be my account or it can be another hacked account to cover my tracks. If there is no role that is interesting for me, I can just create one if I have create role action available. I will create new role with policy that I need and with trust policy for my external account. And there is no good way to prevent me from doing that with service control policy because SCPs cannot read policy contents. So you cannot say that I don't want you to create a policy that has external trust. So either you have to prevent the whole create role action, unless you are a privileged role, or you just need to be sure that you will detect these kind of trust policies immediately with, for example, AWS config that will trigger Lambda. Lambda will check the content of the policy and then will mark the role as non-compliant. Next one, identity provider. And here we can use our external identity store. We can use IDFS, Azure AD, Okta, whatever. And then I create the identity provider on your AWS account. I just need this identity provider to be able to assume a role. So the role needs trust policy. And that's it. Then logging into external identity store, I can log into your AWS account, get a role on your account, and do whatever the policy allows me to. And also, 2 actions needed, only 2 actions. So it's pretty easy, and when companies are using different ways in, different mechanisms like AWS SSO, they are not looking there. We can easily prevent it with SCP, just preventing anyone from creating OpenID provider or some provider unless you are a privileged role. And I use this privileged role here because I have full automation for my accounts and for my access models on AWS. Running on a single account, I have a Terraform that assumes role, this privileged role, on all my organization accounts or accounts from different organizations as well, trusting my account. Then I don't want anyone to tamper my my access models, my roles, my identity providers. So that's why I use this kind of SCPs on my organizations, and only my pipeline with my role can modify access models. Let's jump to the second group, servers. First one, just start a new public EC2 that has a role attached to it. So to do that, let's prepare. First of all, I want to have an external account on which I will run my EC2. I will log into that EC2, create a new user, local user on that EC2 with SSH key added, so I can easily SSH into it. Then I will bake AMI out of this EC2 and share this AMI with my target account. Thanks to that, when I get access to that target account, I can start new EC2 from the shared image. Why? Because then I don't need to create a new key pair on your account. I don't need to configure this new key pair, etc. I will just start the account with no keys, start the instance with no keys, but there is my user already on the instance, so I can log in. I just need security group ID, subnet ID, and instance profile ARN. And I can easily get that running describe instances and finding the instance that has an interesting profile like Jenkins. And also, I can check instances that are already public to get the security group and subnet ID. And then I will have my my EC2 that I can access externally, and it will talk to your AWS account. Next thing, how to prevent it. We can create a new account called, for example, a bakery, where we will bake all our images. like a golden image factory where you create a new image. Let's say you use Ubuntu, so create a pipeline that will create Ubuntu EC2 that will harden it, and then after running sys benchmarks or something like that, when you are sure that this image is secure, then you can create the image out of this instance and share it with your organization, with all accounts, all teams that need to run something on Ubuntu. And then you can use service control policy that will prevent starting new instances from AMIs, from images, which are not yours. So if you can set either one account ID here or a list of account IDs, and then only images that are owned by these accounts can be used to start your new EC2. Next one, let's say we already have a public EC2 with interesting permissions on it, and what we want to have is a local user with SSH access, so that we can access it anywhere and from anywhere and anytime we want. How to do that? When I am doing my research, sometimes I find config files with the IP, username, and password, so that I can directly log into the EC2 and create my user there. If not that, there are two services, at least two services on AWS that can help me doing that. First one, Session Manager. If there is the SSM agent installed on the instance, and usually there is one installed, then the instance is managed. And I can start a session on that instance, and it will be a sudo session, so then I can create my user. If you don't want to start a session and to do it manually, then you can use another tool from SSM. You can use run command, then provide details for that document on run command, and the user will be created on that managed instance. And it will give you SSH access to the instance, so as long as the instance is public and security group allows you to do that, you can access it, and thanks to the IAM role attached, you can talk to AWS as this instance. What's needed? We can start with no actions at all if we have direct access to the instance with SSH from leaked credentials file. But if we don't have that, we need SSM start session or send command and any information about the EC2 that we want to attack. Preventing it, it's kind of hard. So first of all, we don't want any public EC2s. There are load balancers that can be put in front of that, and we should keep our compute resources in private subnets because this makes my life harder. And to prevent people from running instances in public subnets, you can you can add tags to all your public subnets, like subnet type public, and then the SCP will prevent them from running instance in any subnet tagged with subnet type public. It's not a perfect solution because they can just remove the tag and it's not tagged public anymore, so they can just run the instance then. And also you can take a look at security groups to have granular access, but if you have your public EC2 with security group preventing me from accessing it, then you are just one click from me accessing it, because anyone can make a mistake and remove something or add a new rule, or I can do it. Then group 3, network access. This one starts with security group and just adding a new rule to existing security groups for public resources. So the thing I mentioned earlier, you can just you can have your one layer of protection, public EC2 and security group on that EC2, saying that only my office IPs are allowed to access the machine. But it's only one click from anyone accessing it. So I can just add my rule, and then I will access the same resource. So it's not a good idea to run any instances in public subnets. What's needed? just the authorized security group ingress or egress if I want to extract something, or if I want to initialize connection from the instance to my, my servers. And preventing it is not easy because we don't have a SCP for that. So we can try not having public resources, so not running it in public subnets, and not running in instances. If you really need to have an instance in public subnet, do not attach a role to it. If it's just a network resource, then the scope is limited. But if you give it a role and access to your AWS API, then I can access your AWS API. Also, if you only have security groups, think about network access control lists as a second layer of protection. Usually, when junior attackers access your account and they see, oh, there's only security group, they know how to add a new rule to security group. But if there is an ACL, holy shit, what's that? I don't know how to add a new rule there, so they will just leave you alone. And there is also a way to detect changes in our security groups. That's infrastructure as code. So if you have everything in Terraform, for example, then if you run your pipeline next time, you will see that there are changes. And you can have like notification on Slack or somewhere that, hey, there were changes and different changes that were expected. Take a look at that, then dig into CloudTrail and find who did that changes, how he got in, and fix your backdoor. Next one, VPC peering. Let's say we have our private VPC, all our EC2s in our private subnets in our VPC, but I have admin access to your account, and I have external account with my VPC, so I can just create peering, cross-account VPC peering, and create a routing between my VPC and your VPC, and I have access to your network. Only one VPC, but still, if you have sensitive workloads there, I have access to it. What's needed? Create VPC peering connection and create route, just to know where to go with your packets. And similar one, transit gateway. Let's say you already have transit gateway configured and you have attachments to your VPCs. And then I have my other external account, and I just share your transit gateway with my account, and then create the attachment on my side. The attachment may be automatically accepted on your side. There's a checkbox for that. And I have access to your whole network thanks to transit gateway, not just one VPC. So what's needed? Just create root and create resource share. But we can easily prevent all our modifications in networking, because usually when you have big infrastructure, you have a different team running networking, and they don't do changes very often. So if they don't do changes very often, you don't want anyone to modify your network-related endpoints with any user, any administrator user. So just deny all creations or attachments of gateways or creation of gateways, any ways in to your network. Let the network team decide who should have that access and prevent anyone else from creating backdoors here. Next group, we have services. And let's start with AWS SSO, now called IAM Identity Center. If you don't use AWS SSO, but you have the organization and you use it the old way, then I can create a new AWS SSO instance for you. And you will not know about it. I will just create this. I will enable the SSO, and I will create a local user store. I will create my user, then a permission set. And this permission set will be propagated across all your member accounts as a role with policy that I decide to attach. And then my user will have admin access to all your organization accounts because you are not using SSO, and I created that for you. So what's needed here? SSO admin actions only. like create user, create permission set, and create account assignment. And then I can access all your accounts in the organization. And how to prevent it? First of all, enable the SSO and configure it to use your external identity providers. You don't want direct AWS access. You want your domain users and SSO, so you manage access in external system and not in AWS. You already have your domain usernames in Office 365, for example, or Okta. So let's manage everything there. And if you configure this with your identity center, then whenever I try to modify or add the user or add group or modify anything, I will get this error message. Oh, sorry, this is all managed in external system. And I'm only admin on your AWS account and not in your other systems yet. Then let's jump to AWS code pipeline and code build. I like using these two to automate my IAM-related pipelines on my accounts, my organizations, because then I don't need to give any external tool access to my most sensitive part of the infrastructure. But I can use the same to play with your accounts. Let's start with creating GitHub repository with part of my Terraform infrastructure, let's say a public EC2, some Lambdas. All my backdoors that I presented today can be in that Terraform. Then I create the code pipeline and create a connection from code pipeline or code star to the GitHub repository. And then I will create a code build job that just runs the Terraform and deploys anything that is in that repository. Thanks to that, whenever I do a change in my repository that I manage and I have access to, it will trigger code pipeline on your account, and it will build or modify resources on your account. What's needed? We need CodeStar connections to create a connection with GitHub, the external connection. You need to be admin on both code pipeline and GitHub organization to create that connection. Then we need to create a new project, create pipeline, and pass a role so that our code build can use our admin-like role. Preventing it is pretty easy with SCP. Just prevent anyone from creating the external connections. If you don't use GitHub or if you don't use code pipeline, code build, or any CodeStar service, then block this. Principle of least privilege. If someone don't need access somewhere, then don't give it to them and prevent them from using something. And then we have our Lambda with public URLs. That one is interesting because I can create a Lambda function in your AWS account that will, for example, restore all my previous backdoors that you just removed. And I will generate a public URL to that Lambda. So that means that I can just take my phone and ping that URL, and the Lambda will be triggered. That easy. So that's my backdoor using Lambdas, and it can be prevented. But first, what's needed? I need permission to create the Lambda URL, so I can create a new function or use any of your functions if there is anything interesting, and with possibility to modify the function online. So if it's not big enough and the code appears in the console, I can just add my few lines that will run with your legit function run. Or I can create my function, add a role to that, then create the function URL and add permission to be triggered by the URL. Preventing? Easy. SCP, and we are not blocking the whole action to create public URLs. We are just forcing users to select the auth type of AWS IAM. So instead of anonymous and unauthorized, unauthenticated access, we will force them to use IAM kind of authentication. And thanks to that, I will not be able to trigger it if I don't have valid credentials. Now I promised hide and seek, and there are two groups here. First, self-healing. With self-healing, let's start with Event Bridge. With Event Bridge, we can have, for example, a cron that will be triggered every day or every month, every week, and it will trigger a lambda, for example, that is hidden somewhere in a region that you are not using. And this Event Bridge cron will just trigger the lambda. Lambda will rebuild my my backdoors and, for example, notify me that, hey, all rebuilt, you can still access the account. We can use step functions and also lambda here. So lambda is my way of self-healing for backdoors. And with step functions, I can have an infinite loop with my lambdas running and running and running. So you break my backdoor, lambda will be triggered to rebuild it. Then we have the same cron, but not on Event Bridge, but on any of your EC2s with proper access. And the last one, CloudTrail. On CloudTrail, we can also have actions that are triggered by your actions. Let's say you just deleted a role that was my role, my backdoor role, and in CloudTrail there will be an event that this role was deleted, and this can trigger my lambda that will rebuild the role. Then I don't want you to find my backdoors, so let's start with the easy one. When I started to work with big customers, I noticed that they had a lot of tools that were scanning their accounts, like Palo Alto or something, and they marked all roles, IAM roles, that were using administrator access policy. So just don't use it. Use power user and IAM full instead. It's the same, but it's not marked with every tool. Then same context. I had a few times that I accessed EC2, extracted credentials from session credentials, and used them on my Mac. And then when I reported this to the company that they have a problem, they told me that they already know because guard duty found an event of using credentials in a different context. So you can use guard duty to find out that I'm already there. But then I started to play with your AWS on the resource that I accessed. So if it's Kubernetes pod, then I'm talking to AWS from your Kubernetes pod. If it's EC2, then on EC2. It's the same context that I was assigned with this role, so it's not marked on guard duty as external access. And this one, office hours activity, for me, it's better to do that in office hours because there's a lot of noise. You are developing things, you are running your scripts, your pipelines, and then if I do my 2 or 3 actions to do something, it will be lost in this ocean of your activities. So totally different than other attackers doing it Friday evening or on Saturday. I prefer to do it on office hours because then, yeah, it's more hidden. And that was the last slide. Thank you for being here with me. If you have any questions, now's the time, or you can just catch me on LinkedIn. Thank you.